Yes, basic terminology and basic concepts. Just I'll discuss the definitions from these onwards. Like, see here, first come to the in our textbook, page number 5. The graphs, how we are going to define the graph, and what about terminology, and what about basic definition. First, coming to the what is the meaning of graph? A graph means here, a graph means a graph G equal to B E. B indicates vertices and E indicates edges. A graph G equal to a combination of vertices and edges which consist a finite non-empty set of V. That is, I'm going to take a finite number of vertices. Let it indicate with V1, V2, divided up to Vn of vertices. These vertices means you can call it in some other name, points or nodes or objectives, whatever it may be. And other family of set E equal to edges. E stands for edges. I'm taking finite number of edges. E1, E2, divided up to En of edges. These edges we can call with some other name, lines or arcs. Okay, such that each edge EI is identified with an unordered pairs VI VJ or VK VJ of vertices. Means if you take one arrow mark, it indicates if you take one straight line, it shows starting point, ending point. I'm connecting the 2 points with one arrow mark. That arrow mark indicates edge. And first starting point, second starting point, we are indicating with vertices. V1 vertices, V2 vertices. So that's why I'm calling E edge means it is unordered pair of V2 to VJ. Means either VK, it is start from VK to VJ or VJ to VK. So the definition of graph means it is a combination of vertices and edges, and which consists a finite non-empty number of set V equal to V1 to Vn. That is, I am taking V1, V2, Vn vertices, and number of edges. It is also I am going to take finite number of edges E1, E2, En. Then each edge EI is identified with an unordered pair VK, VJ of vertices. This is the general definition of vertex. And I will show these definitions, or I will going to explain these definitions with the diagrams also. Just first listen. Next, coming to the examples. In the graph GI, here, I'll show in next page. Here in this figure. Here. So in this I am taking totally B, W, X, Y, U, P, R. Total I am taking edges, vertices V, W, X, Y, U, and vertices are, sorry, edges are V to W, I am indicating with Q, V to X, I am indicating with R, W to U, I am indicating the edge P. So these are the edges. So in this graph, I am taking V, W, X, Y, U are the vertices, and Q, sorry, Q, R, P, or these are the edges. So with these graphs here, I will define the some more definitions. See here, in a graph, that is previous graph I showed just now. In the graph G, that is in figure 7, the points or vertices U and V are adjacent, but U and X are not. It means, what is the meaning of adjacent vertices? U and V. Where U and V? U and V. Yes, here. This U and V are adjacent vertices, but U and X are not adjacent vertices because there is no connectivity from U to X. Okay, just is it showing in the figure? Is it clear? In this figure, U and V are adjacent vertices, whereas U and X are not adjacent vertices. Why? Because there is no connectivity from U to X. See here, in this figure, we have so many definitions. Let me discuss one by one. Next. Here. In the graph G, the figure 7, the points vertices U and V are adjacent, but U and X are not adjacent. Why? Because there is no connectivity in between U and X. Similarly, the edges P and Q are adjacent, but P and R are not adjacent. See here, P and Q is P and Q. Where it is P? As P and Q are adjacent, but P and R are not adjacent vertices. Okay. Although the lines edges P and R are intersecting in the diagram, their intersection is not a vertex of the graph. Yes, this is one of the most important. In this here, the yes, sorry for the disturbance here. In this here, P and Q are adjacent edges, but P and R not adjacent edges. Why? Because P and R are intersecting. The intersection of two lines are not comes under the adjacent edges. Okay. Clear? Here in the figure 7, we have the complete two basic definitions here. What is adjacent? What is adjacent edges? And what is adjacent vertices? Okay. First, in the first example, U and V I'm calling with vertices, not edges. U and V are adjacent, but U and X are not a adjacent vertices. See here in the figure. In the figure, U and V. So first I'm explaining about vertices. U and V. U, V are adjacent vertices because we have connectivity to U to V vertex, whereas U and X are not a adjacent vertices. Why? Because there is no connectivity in between U and X. Next, coming to the next definition, according to edges. In this, P, R, Q are three edges because P is the connectivity of U and W, R is the connectivity of U and X, and Q is the connectivity of V and W. So in this here, among these three, edges P, edges Q, edge P, edge Q are the adjacent edges. Okay. Whereas edge P, edge R not adjacent edges. Why? Because these two are intersecting. The intersection of two edges are not comes under the, yes, they are not comes under the adjacent edges. That's why I'm calling P and Q are the only two adjacents in this figure, two adjacent edges, whereas P and R not comes under the adjacent edges in this figure. Similarly, see in this figure also here, yes, B, A are two adjacent edges. Okay, B and A are two adjacent edges, whereas F, E, F, E, F, E also two adjacent edges. Coming to the vertices, P, Q are the adjacent vertices, Q are the adjacent vertices, Q, S are the adjacent vertices, R, S are the adjacent vertices. Okay, this is here. Next, come to the figure 8 here. In this figure, just now I explained. In this figure, second figure, come to the which are the adjacent edges, which are the adjacent vertices. In example, figure 8, B equal to how many edges are there? One minute. Here, in this figure 8, here in figure 8, the graph G2, that is figure 8, V equal to totally how many vertices we have? PQRS. Just check out vertices. PQRS. Okay, we have PQRS are the four vertices. And how many edges we have? A, B, F, E, D. Okay, so vertices are V equal to PQRS and the vertices set and E equal to edges A, B, C, D, E, F. F is also this cell. A, B, A, B, E, F, D. S is C, S is also there. Why? Because it is a loop. Starting and ending point are coincide. I will discuss that definition later. Yes, see this circle C also because C is the connected from S to S itself. The vertex H to S itself. That is that kind of vertices are called loops. So in this totally, how many edges are there? A, B, F, D, E, and C. So in the graph G, that is second graph, figure 8, the total number of vertices are PQRS and the total number of edges are A, B, C, D, E, F. In the set edges set, observe that E and F are adjacent edges. Yes, here E and F. E and F are adjacent edges. E, where it is E? E and F is here. This E and F are adjacent edges, not vertices. Edges means arrow marks. Next, uh, the vertex Q and AB. Q and AB is the set of paralleled multi-edges with end points P and Q. That C is self-loop. So what is saying in the figure? Q and AB. Q and AB. Where it is Q? Q here and AB. AB. Q and AB are yes. What is saying this? Q and AB is the set of parallel or multi edges with end point P and Q. With end point P and Q. These are the multi edges or multi edge with end points of P and Q. Yes. These P and Q are connecting, P and Q are connecting in the edge. So P and Q are the Q is the A and B set of parallel edges and what about next? And with the end points P and Q, the edge C is self-loop. Yes, this is important. The edge C is self-loop. Why? Because C is starting at S vertex and again ending at the same vertex S. So this is self-loop. Coming to the some more definitions. Yes, simple graph. When a graph is said to be simple graph, simply a graph is said to be simple graph. Simply, it does not have any loops like this. It does not have any loops. That is starting and ending vertices cannot be coincide. If they are coincide, then that comes under the loop. That kind of loops does not comes under the simple graphs. A graph is said to be simple graph means simply it does not contain any loops. Okay, it's a complete definition. A graph in which there are no self loops. Yes, this is most important. Please underline it. Yes, listen carefully. A graph in which there are no self loops is a loopless graph. The formal definition of a graph permits neither loop nor multiple edges. Come to the examples. A graph that has no self loops or multiple edges is called simple graph. Yes, just remember this one word definition. A graph is said to be simple graph. simple graph. Simply it does not have any self loops. A simple graph with 4 vertices and 4 edges is shown in 11 figure A. 11 is here. This is simple graph. Why? Because there is no loops. Total here, how many vertices we have? UVWX, 4 vertices, and edges U2V, 1 edge, V2W, 1 edge, V2X, 1 edge, W2X is another edges. So these kind of graphs comes under the these kind of graphs comes under the simple graph. Why? Because these graphs does not having any self loop. Okay. Whereas in this examples here, figure 11b here, figure 11b is multiple graph with multi-graph is shown in figure B. At least one multiple edge is called multi-graph. Is one is the definition multi-graph. What is the meaning of multi-graph? Here, a graph in which there is no loop and there is at least one multiple edge. Multiple edge is called a multi-graph. A graph is shown in 11b. Yes, 11b means here in this it is multi-graph. Why? Because it has multiple edges. So it has okay. So multi-graph means a graph, it has multiple edges. I will explain the what is multiple edges. So the multiple edges, the word this comes under the here in this figure 11b, A and B are two vertices. Is it clear? For these two vertices, we have two different edges. One is A to B, and one more edge is here. It is in a uh, half moon symbols here. It is an half moon symbol. This is another edge. So A to B, two vertices and connecting with two different types of edges. This kind of graph is called multi-edges graph. Okay, multiple or multi-graph. Okay, so see a definition. What is definition? A graph in which there is no loop and there is at least one multiple edge is called a multi-graph. Okay, a multi-graph is shown in this figure 11b. Similarly, come to the 11c. Let me discuss one by one. 11c. Pseudograph. First, come to the what is the meaning of the definition pseudograph? A graph in which both loops and multiple edges are permitted. Yes, what is the meaning of this? A graph in which both loops and multiple edges are permitted. It means here in previous examples here, this is self loop is there and multi edges are there. If the figure consists a graph which consists both self loops as well as multi graph or multi edges, then that kind of graph comes under the pseudograph. See here. In this 11b is not a pseudograph because it has multi edges, but there is no self loop. And in this 11c here, multi edges are there. B to C. B and C are the two vertices. These two vertices are connected with two different edges. One is direct straight line, one is half moon straight line here, half moon line. So we have two edges. So this is multi-graph. And A vertex A have self loop and vertex C also two different self loops. So this figure having self loops as well as multi edges, that is multi graph. Then finally these kind of graphs are known as As these kind of graphs are known as pseudo graphs here. This is the most important definition. Pseudo graph means a graph in which both loops and multiple edges are permitted is called pseudo graph. Okay. Next, null graph. Null graph means here a graph whose vertex set is a finite but edges set is empty is called null graph. And in figure 11b, it is shown all null graph G5 of vertices. It means here in 11d here. How many vertices we have? A, B, C, D, E. 5 vertices are there. But no vertex is connected with another vertex. Means there is no any arrow marks here. There is no connectivity from A to B, A to C, A to D, A to E. Similarly, there is no connectivity from B to A, B to C, B to D, B to E. Similarly, there is no connection from C to remaining vertex. Similarly, there is no connection with from D to remaining vertices. And there is no connectivity from E to remaining all vertices. So this kind of graph is called null graph. See, null graph. Okay, null graph. Next, trivial graph. Trivial graph means a special type of null graph consisting of only one vertex, and hence no edges. That is G10 is called a trivial graph. Yes, trivial graph means simply here it consists as only one single dot. Here, if you take one single dot in this figure here, I'm taking only a. Here, I'll show it. This is as in this example. Is it clear? It is yes. Only the figure is like this A. In this entire board, I'm showing only A. That is only vertex A. There is no connectivity from these vertex to remaining vertex. Actually, there is no any vertices and there is no self loop also. This kind of graph is called, yes, I'm showing only one dot A. This kind of graph is known as it is, yes, this kind of graph is known as what kind of graph this is? Trivial graph. Simply a special type of null graph, special type of null graph consisting of only one vertex and hence no edges. It consists only one vertex and no edges. 10 is called trivial graph. Okay. Is it clear? So just listen. These are the basic definitions. Yes, what I explained just now. What is multi-graph? Multi-graph means a graph which having multiple edges. Only two vertices, A to B vertex. These two vertices are connected with different edges. Then that kind of graph comes under the multi-graph. Okay. Self loop means what is the self loop? From one edges to one vertex to same that vertex, we have one route map. So if A is the one vertex, I'm taking one edge from A to A itself. Then that is called loop. Means starting and ending are coincide. Then we can say that kind of graph is called self. That loop is that graph have, we can say self loop. Okay. If according to, by using these two definitions, self loop and multi graph. If any graph which consists of both self loop as well as multi edges, that is multi graph. A graph which consists or a graph a combination with these two self loop and multi graph, then that kind of graph is called pseudo graph. Is it clear? Pseudo graph means a graph is said to be pseudo graph if it consists self loop as well as multi graph, that is multi edges. And what about next definition? As null graph. Null graph means what is the meaning of null graph? A graph which having only vertices A, B, C, D, or V1, V2, V3 like that. But there is no single edge. There is no single connectivity to one vertex to another vertex. That kind of graphs are known as, is it clear? That kind of graphs are known as null graph. So a graph is said to be null graph if it consists only vertices, no edges, means zero edges, right? Next definition. Next definition, trivial graph. Trivial graph means there is a only one vertex, A or V1, whatever it may be. There is only one vertex and there is no connection from that vertex to that vertex. Means only one vertex and zero number of edges. Then that kind of graph is known as trivial graph. These are the basic definitions. If you know all these definitions, then the representation of graph and based on certain graphs, you have certain theorems. All that the next topics will become very easy. So please listen carefully these definitions. Next, I will share the screen. Yeah. So these are the some definitions I explained. Similarly, simple graph means it does not have any self loop. Next, trivial group, and next come to the problems. In above figure, we given uh, clearly classify the following graphs given here in figure: simple graph, multi-graph, residual graph, connected graph, and loop-free. So these are the basic terminology in graph. Next, come to the Next, come to the uh, cycle graph. Cycle graph. Okay, a graph consisting of vertices v1, v2, vn, and edges v1, v2, v2, v3, vn minus 1, vn, and vn2 again v1. It means the vertices, each and every individual vertices having the connectivity, and where we started vertex, after visiting all vertex, it will comes under the first vertex itself. Then that kind of graph is called cyclic graph. The word itself we have here, cyclic graph. Is it clear? What is cyclic graph? A graph consisting of n vertices, v1, v2, vn. Which is first, which is last? v1 is first one, vn is last. After visiting that n from v1 to, after visiting up to nth vertex, again we have to come back from vn to v1. If that kind of route is exist, let us suppose. After finally, we have one route from v1 to vn. We have one edge from vn to vn. Then that kind of graphs is known as cyclic graph. Is it clear? Next, these are the practice problems. Just to do it, do practice. Next up, indefiniteness and degree of vertex. Indefiniteness and degree of a vertex. See here. Uh, next, next definition. These are the cyclic graph. Next, there are some practice problems. Do it, practice it. And next, I'm going to discuss the what is in degree, out degree, or inside the degree of vertex. Degree of vertex is again comes under the two types. What is in degree, what is out degree. First, let me discuss what is the meaning of degree of vertex. Okay, degree of vertex means here, let G is a graph with vertices V and edges E, be a graph, and V1 belongs to V, that is any one of the vertex Vi belongs to V, be a vertex of G. The degree of the vertex Vi denoted by D of Vi is the number of edges incident on Vi plus twice the number of loops Vi if any. Means it means here in this figures here. With this figure, I will explain the meaning of degree of vertex. Okay, I will explain the degree of vertex. Just see here in this figures here. If we take any one of the vertex, let me take V1. Okay, V1. I want to count the number of degrees for the vertex V1. So just see from V1 to remaining vertices, how many arrow marks are there or how many edges are there. So here V1 having totally E, E3 edge, E4 edge, E5 edge. Is it clear? V1 having E3 edge, that is V1 to V2, E3 edge. And V1 to V3, E4 edge. Again, V1 to V3, we have one more edge, that is E5. Totally, it has three edges, E3, E4, E5. Then we can call the degree of V1 is 3. Is it clear? The degree of V1 is 3. Similarly, if you count the degree of V4, degree of V4. So from V4 to remaining vertices, how many root maps we have or how many straight lines we have. V4 to V3 we have, that is E6 edge. V4 to V2 we have E2 edge. V4 to V5 we have E7 edge. So totally for this one also we have 3 degree. The degree of V4 is 3 and they are E2, E6, E7. Okay. So the degree of vertex means, and one more thing, if you count for V2, if you count for V2, V2 have special case, that is it has loop. Is it clear? It has loop. If it is loop is given, we have to count that number of edges must be twice. That is clockwise, anti-clockwise. Even repeated 2 times. Like that, we have to count 2 times. So clockwise, if you start with V2, again we can reach V2. Anti-clockwise also you can start from V2 to, we can reach again V2. So whenever a loop is given, that is closed self loop, closed loop is there. For that, we have to count the degrees 2. We have 2 routes. We can start clockwise, we can reach again V2. If you start anti-clockwise from V2, we can get the V2. So if you count the number of degrees for V2, here, I want to count the number of degrees for V2. How many degrees are there? Yes, V2 to V4, we have one edge, that is E2. V2 to V1, we have one edge, that is E3. And V2 to V2 itself, we have even degree, even edge. But it having cycle means we have to count this as 2 times. So totally V2 having, the vertex V2 having 4 edges, E3, E2, even 2 times. So totally the degree of P2 is 4, like that. Just to count the number of edges are there. The total number of edges are known as one minute. Clear? Here. So the number of edges, please listen. The number of edges or the number of degrees is the degrees. How we are going to count the degree of particular vertex? From, I want to count the V1 vertex. From V1 to remaining vertices, see how many roots we have, how many straight lines we have. That total number of quantity comes under the degree of vertex. Okay. And if it is vertex V having V1 or V2, whatever it may be, it having loop, then we have to count that is two times, because clockwise we can get one root, anti-clockwise we can get the another root. So whenever a loop is given, the total number of degrees can be counted as a two times. Okay. So the total degree can be of particular vertex can be how many root maps are there from that vertex to remaining vertex, or number of edges for that individual vertex is known as the degree of degree of vertex. Okay. And this degree of vertex can be divided into again two types. One is in degree and another one is out degree. The degree of vertex can be uh, counted as a two types: degree of in degree of vertex, out degree of particular vertex. Coming to the what is the meaning of in degree and out degree? In degree means here in degree. Whenever I want to count the in degree, out degree, first we have to indicate the arrow marks. That is directed graph. First, let me discuss the definition of directed graph. A graph is said to be directed graph. It means if the directions must be mentioned. If two vertex are there, V1, V2, just I am connecting with one straight line. I am not putting any direction, whether it may be V1 to V2 or V2 to V3. If the arrow marks are not mentioned, are not assigned, then that is comes under the only graph. If arrow marks are mentioned, exactly I'm saying V1 to V2 or exactly V1 to V3, then that kind of graphs are directed graphs. Okay. Suppose V1 to V2 or instead of V1 to V2, if I indicate the arrow marks reverse case, V2 to V1, then that is also directed. But it is directed in uh, reverse format. So depends on these directed graph. Again, I will going to discuss the two more definitions: in degree of vertex, out degree of vertex. Come to the what is the meaning of in degree? In degree of vertex means if you take any one of the vertex V1, V1 to how many root maps are there from V1 to other vertex? It is not inside. We have to leave the V1 to other vertex. Okay, in positive direction, in forward direction. It is not backward direction, forward direction. V1 to V2, V1 to V3, like that, V1 to V4. If three roots are there, then we can say the in degrees, the out degree of vertex is 3. Whereas in degree means it is reverse case. V2 to V1, V3 to V1, reverse directions. That see how many vertex are there, how many edges are there from V3, V4 to V1. Just count all that. That indicates, that number indicates the number of in degrees, out degrees, in degrees. I will show these two definitions in one figure. And as here, the total degree of a particular vertex. Yes, remember, the total degree of a vertex is given by sum of in degree of that vertex plus sum of out degree of that vertex. Yes, I'll show it. See here, I'll show that what is the in degree, what is out degree. Yes, this is directed graph here. Arrow marks are indicated. And this is undirected graph. Arrow marks are not indicated. Whenever arrow marks are indicated for that graph only, we can discuss what is degree of graph, what is in degree of graph, what is in degree of particular vertex. See here, for example, cyclic graphs, of course, we finish this all definitions. And direct, yes, here we have seen. Directed graph means, see here, the meaning of directed graph is, let G is a graph with a vertex V, index E, be a graph and Vi belongs to V, be a vertex of G, then the degree of the vertex, Vi denoted by degree of V, is the number of edges. How many edges, whether it may be in edge or out edge. Okay, that the total number of edges on V, and count whenever it is a loop is given, count it as a 2 times. All these number of loops of Vi is the degree of vertex. If G is a simple graph, then degree of V is simple. The number of neighbors surrounding, the number of degrees surrounding V is like this. Okay. So here, I can take one example and count what is the degree of uh, individual vertices. So here, a vertex of degree 0 is called isolated vertex. Means if any one of the vertex is given, from that vertex to remaining vertex, there is no connectivity, there is no edges, then that kind of vertex is called isolated vertex. Or simply we can say the degree of that vertex is 0. Okay, a vertex of degree 1 is called a pendant vertex, and a degree with vertex degree is 0, then that is called isolated degree, isolated vertex. A vertex, it does not have any edges, then it is known as isolated vertex. If a vertex, it has only one edge, that is called pendant vertex or a leaf. In this here, in figure 13, let me take an example this. Yes, this is, listen carefully. I will explain the in degree, out degree, sorry, total degree of, or the degree of vertex in this figure with this figure. Here, in this we have total how many vertices are we have? V1, V2, V3, V4 up to V5. Sorry, V6. Total we have V6. Here V6 also here. This V6 does not have any connectivity. So this is the number of edges are 0. Means this kind of vertex is known as isolated vertex. Isolated vertex. See here in this figure V5. V5 having only one edge, that is E7. V5 to V4 we have only one edge, that is E7. These kind of vertex are known as pendant vertex. So in this figure see here, V6 is the isolated vertex and V5 is the pendant vertex, because V6 having 0 edges means isolated, and V5 is the only one edge, that is E7. Therefore V5 is called pendant vertex. Here, see, just I want to count the number of edges. So consider the figure example 1.4.4. Consider the figure 13. The degree of the various vertices of this graph are figure given by, totally how many vertices we have? V1, V2, V3, V4, V5, V6. Totally six vertices are there. I want to count the each and every individual vertex number of edges, that is degree. So here V1, what is V1 number of edges? V1 having E3 edge, E5 edge, E4 edge. So the degree of V1 is 3. See here, the degree of V1 is 3. Similarly, the degree of V2 equal to 4. See, so that is 2 or not. Let me check. V2 how many edges we have? E3, E2, but it has one loop. Whenever loop is given, I already told, if loop is given, just count twice. So 2, 2 plus E3 plus E2, totally 2 plus 2, 4 edges. So 4 edges means the degree of V2 is 4. Okay, degree of V2 is 4. Is it clear? Next, V3, V3 having here, V3, where it is V3, yes, V3 is here. Yes, V3 also having three edges. One is E6, E4, E5. Okay, similarly, see V4, V4 having three edges, E7, E2, E6. Okay, E2, E6, E7. See here, V4 having three edges, V3 also three edges. See, what is V5, V6? V5, V5, where it is V5? Yes, V5 having only one single edge, that is E7 only. Okay, whereas V6, it is isolated vertex. Why? Because it does not having any connectivities, or it does not having any edges. So V6 having the zero edges. Okay, next. See here. Next, coming to the, this is one theorem. We will discuss this theorem next class. Before stopping the class, still we have 5 minutes. Just I will explain the in degree, out degree. Yes, in degree, out degree. See here. 1 minute. Wait. Where it is all these are comes under degree of vertex. See here. If I am getting low battery, okay, just within 2 minutes I will going to stop the class. Degree of 4, okay. So director, this is not director graph. Whenever director graph is given, then I will going to explain the number of edges, number of degrees. All these are the undirected graphs. All these are undirected graphs. So same the topic, it can be expressed in this next unit. I will show it. 1 minute. It is directed graph is there. Directed graphs. There it is. Connected, disconnected. Okay. Okay. Just see here. Let me discuss that later. Next topic, subgraphs. Okay. All these are the examples. Next, subgraphs. Subgraph means it is a graph. From the graph, we have to delete few edges, few vertices. Then frame a new graph. That graph is known as subgraph. Here, the definition of graph. Let G is the graph with the vertices V and edges E. A graph. A graph H is another graph V dash E dash. V dash is the sub V dash are the number of vertices and E dash is the number of edges, and it is called subgraph of G if all the vertices and edges of H and are connected in the vertices and edges of the G, that is VI subset to V and EI subset to E, and each edge of H as the same end vertex in H in G, then it is known as subgraph. Okay, see here, I'll show it here. This is graph. 16 figure is 16G's graph, and 16Gi is the subgraphs, because here I am eliminating few edges, few vertices. So these kind of graphs are known as subgraphs. Okay. Okay. I'm getting low battery. Okay. I will go to stop the class. Let me discuss in next class. Okay. Almost it is time is also as